Are vectors giving you a tough time in your physics revision? Well, you've come to the right place. This explainer is built to help you absolutely crush vectors on your WAEC, JAMB, and NECO exams. We are going to cover it all. From the basic ideas to solving real problems. Alright, let's jump right in. So here's our game plan. First, we are going to nail down what a vector actually is. Then, we'll build your problem-solving toolkit with all the essential skills. After that, and this is the fun part, we'll use that toolkit on real exam questions. And we'll finish up with some key tips to make sure all this knowledge sticks. Okay, let's get into it. What is a vector? We have to start with a solid foundation. So what's the big deal with vectors? Well, it's simple, but it's so important. A vector answers two questions. How much? That's the magnitude. And which way? That's the direction. Think about it. If you say you're driving at 100 kilometers per hour, that's only half the story, right? Are you going north or south? That direction part is what makes it a vector. Okay, you are definitely going to see this on an exam, the difference between a scalar and a vector. Scalars are easy. They are just numbers. Your mass, the time, they only have a size. But vectors, like force or velocity, they feel incomplete without a direction. A force of 10 newtons doesn't mean much until you tell me if it's pushing up, down, left, or right. The key question you always have to ask yourself is, does direction matter? Alright, let's build up your vector toolkit. These are the operations you absolutely need to master. You know, we draw vectors as arrows. And it's a really smart, simple visual. The length of the arrow tells you its magnitude, a longer arrow means a bigger force, and of course the arrowhead points you in the direction. Getting comfortable with this visual language is the first real step to solving problems. So how do you add two vectors? Well, you just chain them together. It's called the head-to-tail method. You take the start of your second vector, its tail, and stick it on the end of the first vector, its head. The final answer, what we call the resultant, is just the shortcut. It's the one single arrow that gets you from the very beginning to the very end. And here you can see it perfectly. We've got vector A, and then starting right where A finishes, we add vector B. That third vector, A, the resultant, shows the direct path from the start of A all the way to the end of B. It's like the total result of taking both journeys. Now for a real game changer. This tool is called resolution. Instead of putting vectors together, we're going to learn how to break them apart. And trust me, this makes some really complex problems suddenly seem a whole lot easier. Here's how it works. You can take any vector and split it into two parts, a horizontal part and a vertical part. Now don't let the formula scare you, they are actually super straightforward. For any vector, v, at an angle, theta, the horizontal piece is just v times cosine theta. And the vertical piece is v times sine theta. If you can master these two little formulas, you've got the secret to cracking projectile motion problems. Okay, this is where the rubber meets the road. Tackling exam questions. We've got the theory, now let's see how it works on real problems from past papers. Our first one is from a 2011 WAEC paper. They give us three different vectors and ask for the resultant. Now, before we solve it, just take a second, pause and think, what would your first move be? How would you start this problem? Your first move, always, is to visualize it. Just like the question asks, you draw it out. A quick sketch isn't just about getting marks from the examiner, it's about helping you see the problem clearly before you even touch your calculator. So what's the strategy? We resolve. It's like divide and conquer. We break each of those three vectors down into its simple x and y parts. Then it just becomes basic math. Add up all the horizontal bits, add up all the vertical bits. Once you have those two totals, you use a little Pythagoras to put them back together for your final answer. Okay, listen up, because this is a classic trap. It's so easy to make this mistake. In your calculations, directions like west and south have to be treated as negative numbers. If you forget even one of those negative signs, your whole answer will be wrong. It's such an easy way to lose marks, so be careful. Alright, you ready for another one? This JAMB question kind of flips the script. This time, they give you the answer, the 100 Newton resultant, and you have to work backwards to find one of the original forces that made it. The second you read the words, at right angles, a little alarm should go off in your head that says right-angled triangle. The key to everything is to draw it. The two forces are the two shorter sides. The 100 Newton resultant is the long side, the hypotenuse, and you've got your 30-degree angle. Once you have that picture, the problem almost solves itself. And once you've got that triangle drawn, you're basically home free. It's just simple trigonometry. The force we're looking for is adjacent to that 30-degree angle, so we use cosine. Hypotenuse times cos 30. So, 100 times cos 30 gives you 86.6 newtons. Answer, D. Just like that. And for our last one, let's look at a conceptual question from NECO. This time, no calculators needed. This is all about testing if you truly understand what a vector component is. Which one of these options do you think describes it best? The answer is A. Now, that's a bit of a technical way of saying it, but it just means the component is the vector's affective value in one specific direction. I like to think of it as the shadow that the vector casts on an axis. It all connects right back to that v cosine theta formula we put in our toolkit earlier. Alright. We've covered a ton of ground, so let's wrap this up and boil it all down to the absolute must-know tips for your exam day. I want you to think of this as your exam day checklist. Number 1, always draw a diagram. It helps you think and it gets you marks. Be super disciplined with your axis. North is positive y, east is positive x, watch those negative signs. And finally, practice with those common angles, 30, 45, 60, so you can solve them fast. Get these habits right and you'll be unstoppable. So, I've got a question for you. After all this, what vector concept do you think will be your new secret weapon? Is it the simple elegance of adding vectors head to tail? Or is it that powerful tool of breaking them down into components? Find the tool that really clicks for you. Make it your own and walk into that exam ready to ace any vector problem they can throw at you. Good luck.